Welcome to Voderady, to inoBat. This is actually Slovakia's first battery production facility. In this 9,500 square meter area, we do both R&D, research and development, as well as production of high-performance cells. So mostly for aviation and high-performance sectors that require special level of chemistry that give you enough power density, enough energy density. Okay. And this is a product we've been developing since inoBat came into existence in 2020. We have a strong R&D department that has now developed 4th generation of chemistry, which we're now bringing to the market. We have started in the eVTOL application, so basically commercial aviation. And now we are adapting this chemistry also for the needs of what we believe Europe needs now, which is defense type of solutions as well. So what you will see is anything, and we are currently retooling the line for actually the switch to a new product for a new customer. So you will see actually that the activity is focused on basically the capex and the retooling of the equipment, but we'll take you to a room where actually we are basically putting it all together, the formation room, which is kind of the life of the battery, where electrolyte injection happens, and you can see that the process when the battery comes to life, when the cathode and anode materials are put together, stacked, and the electrolyte is injected.
Looking forward.
Welcome to the tour. What we are up to today, and then we'll take you to an R&D lab, so you can talk to the scientists and what they're working on. Okay?
Yeah.
So this is our administrative area. We have over 100 people working on R&D side, manufacturing, logistics, finance, legal, procurement, and now we're going to take you from the admin office area to actually production and R&D. Okay? Hey Arthur, you're on the camera. Smile. Philip, you're on the camera. So this is our health and safety manager. We take pride in actually having 0 accident days for how many days now?
More than 2,000.
More than 2,000, yeah, so good track record. We keep the operations lean and safe, and Juraj is doing a great job. So now we need to put you in a coat. You've done this before, right?
Sure.
So Juraj will dress you up. Okay, looking good. You got extra large. This is probably the biggest coat we have, huh? We haven't had many taller people than Simon here. So Simon, you have to do this, obviously. So it's kind of a little invention. You have to just pull, like Bayern Munich footballers, like go like this.
We'll do that.
You pull back.
Smart.
Yeah. So you save your back. I know you're a yogi, but yeah, that's good. Hey, you finally got it. Stronger. Okay, perfect. All right. So now, thank you, Ray. You're coming with us, right?
Yeah.
So basically, you've already been to a battery production, right? This is where we get the materials from. This is our inbound area. We basically function on just-in-time basis. So the materials are coming in based on our needs. This is our air shower. Make sure that we don't bring any nanoparticles to production. We have to keep the battery safe from what humans bring from the outside of the world. And this is a dry environment, clean environment. It's in terms of standards, it's comparable to biotech or pharma industry. So you need to really keep a special level of cleanness to make sure that the production happens as expected. So today we actually are mixing. So what I suggest, we actually I'll take you to a map where I explain the entire process for 5 minutes. Mm-hmm. Then we'll just take a real quick look, and then we'll end up information. Okay? So there's a map that explains the whole process. I mean, you've already seen battery production, but basically just wanna remind you, Thank you. So basically, this is the entire layout of production, right? We start with the mixing, and then basically, the process continues through different chambers, which represent different part of the process, from coating, calendaring, slitting, notching, vacuum drying, stacking. All of this basically happens in the formation area, where we're gonna spend some time. And this is where actually the battery comes alive, right? You have two parallel, cathode and anode, manufacturing basically sites, and in the formation is actually where they all come together, and you do the stacking, you do the X-ray, you do the electrolyte filling, and basically the battery comes alive, right? So I'm sure you've seen this before, and what I suggest is that actually we take maybe videos of the mixing, the coating calendaring area, and then we spend a bit more time in formation where the operators are waiting for you. Okay? Is that okay?
Yeah, looking forward.
All right, so let's start the tour. I always say that production of batteries is like making lasagnas. You have to come up with the recipe. So today you see guys mixing our high performance chemistry. We are NMC based, company. NMC cathode, silicone and graphite on the anode, and it gives us the right combination of power and energy density, to power high performance applications, like aviation, eVTOL.
Everything here is prepared basically to have the prototyping production, small serial production and development of everything. That's why all of the machines are not connected with the conveyor lines, robots or something else. That give us full flexibility for the production. We can repeat the process, we can skip the process as much as we want, we can redesign it, or even skip the process and then return it back later on if necessary.
Thank you. So welcome to our lab. Hello. This is Lukáš, our R&D scientist. This is Simon, who's making a cool podcast.
What is most important, as I mentioned, 90%, let's say, of the R&D, of the development, of the chemistry are done in these small cells because it's cheap, it's fast, and it's easy.
I would just prepare an example of half cell for testing the cathodes. So as Lucas said, we are always supporting the production line. And if we have a production of a new cathode or a new anode, to make sure that we can take it to the assembly of the full cell, we will first check that we have the good capacity and that everything is good and uniform with our electrodes. To do that, we are preparing half cells. That, as Lucas said, it's like the cathode or the anode when we pair it with a lithium metal chip. And by doing that, we can see what is the exact capacity of the electrode that we prepared in the production line. So we start with something that is called spring. Eventually, we need good pressure inside the cell so that there will be good connection between all the parts of the cell. On top of that, we are putting the spacer with the lithium metal, if it wants to come. So we have a half cell already prepared. Another component that we are using is, of course, the electrolyte. And this is also something really good in this, let's say, configuration of cell, because the amount of electrode and the amount of electrolyte that is needed in order to do the testing is really small. Therefore, you can do a really big matrix of experiments using different materials and different additives to the electrolyte, different compositions, etc. Then we're using our spacer. Our separator to separate the electrical. It's not a good one. The electrical conductivity between the cathode and the anode. As you can see, it's really well wetted. And on the other side, we're using the cathode, if they want to separate. Yeah. Facing down. Once we have everything prepared, we can take the other cap and close the cell. And as we showed before, we need to seal it. It's very easy. And then we have the cell prepared for testing. And using these cells, we can do hundreds of cells, testing different materials and different electrolytes.
You can check it like the thickness, if it's on the same edges and in the middle has the same thickness, or we have some problem in the manufacturing or not. Now we are testing like the shrinkage of the separator, yeah, because this machine can measure lots of, let's say, other things and how to work. Yeah. And now we can go to this presentation of the cell, what we already prepared with our production partner. So, as I mentioned, we developed in the 2022, let's say, the few chemistries, but it was only in this laboratory scale. So we have this production partner, first in the Korea. So this was the first cell, like the E65. This E and the number means like the ampere hour. So this is like the 65 ampere hour pouch cell, and this was the generation 2. Yeah. And then with them we prepared this E33 model. So it means like the 33 ampere hour. And you can see, or even you can touch it, it's like really, let's say, gel. And this is the generation 1, the E60B. And here you can touch it and compare it, like this is like the 60 ampere hour, and it have like the almost 1 kilo. And this is like the 33, so let's say almost half, and has only the 330 grams. Yeah. So you have the half capacity, but the third weight. Yeah. So this is like this difference between generation 1 and generation 2. Yeah. So this was already done in this Taiwan, the another, and then we get the another, let's say, optimization of this generation 4. So here you can see that it's not so liquid as the first version. And then we go to the E33B, which is really solid. Yeah? You can take it, that it's not so jelly, and it's like the, let's say, optimize this this electrolyte amount. Yeah? Between this E33-7, so it's like the, let's say, same format but more layers, so you get the more capacity. And then when we build this Volta 1 in the inoBat, so first we do the setup of all the machine, if it's work and so on, and the training of the people in the generation 1, yeah, because it's like the less expensive, it's like more robust, you don't need to like the it's not so sensitive for the environment. And when we set up this, we jump with the Lilium to this project of the F10 cells. So it was like the, let's say, really similar dimension of the cell, what we prepared before, but the chemistry was done by the Lilium, yeah, because from the certification and so on, it was not hard to change it. But this was like really demanding, let's say. They was using some special, let's say, coating, and it was really hard to handle it. So then we developed something with the Gaussian, so the Lilium inoBat Gaussian cells, which was the chemistry was really similar what we are now preparing, but then if, as you know, the Lilium go to the bankruptcy, so now we are doing our internal, let's say, project about the fourth, let's say, almost different optimization of this generation 4. Yeah? So now we will produce it, or the three, let's say, 3 or 4 different prototype with the different 2 electrolytes and the separator, and then we choose the one option which is the best, and we produce it like the thousands of the cell and offering to the potential customers, and it will be like the really European-made high performance battery what we prepare in the inoBat.
At this moment we are at the formation area. Basically what is happening here when we have the battery with the electrolyte, when we have the entirety of the
ready to go cell, we are following to the first ever charge the battery, and also for the electrochemical testing. There is final chemical processing here, and also there is full-scale testing, depend on the model, depend on the requirements from the customer, how it should look like in the end, what kind of parameters it should have. This machine behind here, it's basically one of the critical machines for entirety of the process. This is the second most important process for everything that is happening within the manufacturing of batteries. Formation unit, the first ever charge and additional charges are done here. This is super precise process that we need to do very carefully, very slowly to create the chemical solid electrolyte interface. During the first charging, there are reactions between the electrolyte and also active materials that you have inside the battery. Everything happens here. Basically, automated system is bringing tray like you have in the front here, unload all of the batteries from it, and then place it inside the charging station, the nests. Everything depends on how much you want to pay for the manufacturing line, what kind of functionality do you want. We design the entirety of the line to be as versatile. Most of the machines in the previous processes are standalone, to have the versatility, to have the easy to do modification on it. And we exactly get this kind of quality from the equipment. Of course, you can have better equipment, higher technology, more advanced system. With these machines, we have the ability to adopt it, like CT scanning over the line, end of the line inspection, additional AI that is taking care of the vision systems and so on. We have the available space on the machines. We are able to basically adapt those kind of solutions to existing one line. Okay. At the end, we are also checking the plateau. This is exactly how the almost final version of the battery looks like. We are checking entirety of the dimensions, what is the thickness for entirety of the plateau. We were working for now with the automotive and also aerospace, where you have very high requirements towards the total mass for the battery and also the physical dimensions. In the car you have a lot of space, you can spare some additional mass to have the higher capacity, but in plane every 1 gram counts, and entirety of the space that you have available inside the machine, the flying vehicle, is very limited. So 1 to 5 grams additional mass of the battery, basically it will give you additional space for one person, or it will remove it.
So this is, just to give you an idea, speaking of innovation, you know, there's innovation on the chemistry side, but then there's innovation on the construction side, right? And what we did, back in the days, there used to be Samsung as the main employer in Slovakia producing LCD screens. And after tax holidays expired, you know, Samsung decided to move to Vietnam. And they left us with this amazing infrastructure. So lots of warehouses, they were built by the Koreans. So we bought one of these warehouses, and this is actually what it looked like before when we acquired it. So you see the before and after. And in 18 months, we turned into actually an R&D and a battery production house, right? So what I love about Slovakia is that actually we have a very strong manufacturing heritage. You know, we have built the automotive sector in 20 years. You know, we went from just an idea to becoming #1 car manufacturer per capita in the world. So I told everyone, why don't we become battery #1 manufacturer per capita in Europe or the world? We already have a precedence where we have done it. The automotive, the performance world needs high performance batteries. And this is how inoBat got started, right? Basically, we're inspired by Slovakia's transition from kind of an agricultural country to actually a leader in automotive. And so you see, in 3 years since inception, we built this. So the first battery production in Slovakia. And what you see is the future. All the way to that forest, it's 70,000 square meters, where we want to build Volta 2. So it's the expansion, the gigafactory. You know, we have always believed in the motto that you should start small, learn the trade, you know, on a smaller level, and then scale up fast, you know. So you avoid mistakes of other players in the market who went big, you know, large gigafactory production, and then they found themselves with a low yield and issues with customers. So we have tried to do it the other way around, start small and scale up fast. So this is actually the future. And as I mentioned to you, we also have a joint venture project in place with Goshen called GIP, which serves the mass market. So Voděrady is for the high performance NMC chemistry. And here, what we want to build is actually a market booth, basically customer dedicated up to 0.5 giga, 1 gigawatt hour lines for different applications, from high performance to low voltage. So this is actually a new project that we are starting working on later this year. You know, you need to be able to actually incorporate some of the latest chemistry, you know, discoveries that you see, whether it's sodium ion or, you know, solid state, or in our case, you know, we have really focused on the silicon anode as a ready to go to market chemistry, so that we can actually power planes, you know, human drones or unmanned aerial vehicles, right? Sure. So we dealt with actually the materials that are available and that are scalable, right? But at the same time, our R&D guys are working on, you know, solid state research, sodium ion, just to stay competitive. And the beauty of this setup is that actually you can compartmentalize it, right? You can actually run different programs. You are not married to basically 20 gigawatt hour, one chemistry, one customer, and then when there are some issues with production or on the customer side, then you get in trouble, as we've seen with other players, right? So this is a more kind of a versatile model that allows it to be flexible, adaptable, and that's the beauty of a smaller production booth.